So my name is Matt Nanny. I work with AECOM. I am the Enterprise GIS and Remote Sensing Manager. And so what I try to specialize is the nexus between different types of GIS data, UAS data, other types of remote sensing data, and bringing that and visualizing that data to the public. A couple key challenge questions here, just talking about data collection. What is good data? What is the value added to that data? And how do you share that data? A lot of times we'll come up with a need, base that need off to the acquisition, to the deliverable after the data processing, and hand it over to a client, and they're like, cool, this is really neat. Thank you. They put it on a shelf and they never look at the data again as part of that. So part of the way that we're trying to, I'll progress here to the next slide, is to integrate that into more aspects of what the data needs are. So right here is an example of kind of like, I'll call it the verticals or overlapping Venn diagrams of what we do as a department and how we get to those data deliverables. A great case in point is using satellite-based imagery to, say, derive NDVI data for plant vegetation health as it pertains to either looking at plant health assessment, but more so to look for obstacles that may be in the path of someone doing a very thorough survey in the field as part of that. Drones are going to be heavily talked about here today as well, but I also want to talk about the enterprise mobile applications, what we call EMAP at AECOM, for both survey and inspections, as well as a mobile platform for those, and where those two nexus. It's a quick overview of the pilot program here, or the program for training pilots. We take that safety concerns very seriously. We also try to train subject matter experts to become UAS pilots as opposed to the other way around for that. So a couple minimals, we have 3 to 5 day flight training time. That's been largely hybridized to online training and then an in-person training as well. And we also really preach for flight currency as part of this. Another part of the technical side, talking about the breakdown of what you need to have a successful UAS project for that. The surveyor, the pilot, the data processor, and the analysis and design portions thereof. So what does that mean? Does that mean every one person is going to wear all 4 of those hats? Not necessarily. A lot of the times I'll wear 2 to 3 hats depending on a project, but say rely on the surveyor to be out there to be able to set the ground control to tie that back to a level of absolute accuracy for that data. Concerning the piloting portion of it too, that's something to focus on a bit. That is a totally separate skill set. I love that a lot of times people gloss over that portion of UAS flights. They say, okay, yeah, you go out, you got your certification, perfect. Well, that doesn't mean you're going to be a safe pilot. That doesn't mean you're going to successfully collect data as part of that. So we really focus on just the purely piloting aspect of that program to be able to really train safety and have flight integrity for that. And the data processing here, I'll get into more examples thereof, as well as the analysis and design. Here are a couple of different project examples or bits and pieces that came from other project work as part of that, talking about some of the common verticals that are assessed there for that. So thermal imaging for infiltration of water, hot and cold contrast, and potentially species monitoring as part of that. That's something we're looking into more heavily now. As far as photogrammetry and LiDAR, I know we talked a lot about that in the earlier session as part of that, but coming up with different types of models, and I'll give an example here where we're using both photogrammetry and LiDAR to varying degrees of success. As well as analysis. AI machine learning certainly play a larger aspect, especially when it comes to image analysis and image segmentation as part of that, but also doing change detection, just simple things that are from recurrent UAS flights. So if I fly today and I fly in a year, what does that change look like? What changed between today's flight and then the flights from a year from now? So more of a Venn diagram on the technology itself as it stands with current capabilities. We've made some large investments in BV loss technology, and I'll give some better, more salient examples here in a moment as part of that, but we see this progression moving towards what is the vertical that we're trying to do? What is it that we're trying to achieve with that? Can I fly longer, faster, map more in a given day and cover thousands of acres as opposed to covering hundreds of acres in a day for photogrammetric data capture or even potentially LiDAR thereof. There is a LiDAR payload for that one drone up in the right corner. There you go, Census Centero V2 BB-LOS. And really to bring it home on the conference and the focus thereof is what are some of the GIS mobile data collection opportunities out there? Certainly that classic of creating that baseline orthomosaic map for site audits is huge. We do that quite frequently as part of project deliverables. But then incorporating other aspects of enterprise data collection, case in point, going out and going and mapping a catch basin, bringing that data back in, but then also overlaying in the GIS on the web component of that with the survey 123 data of those assessments. So not only are you seeing a report that really facilitates the deliverable to the client, but you're also seeing that interactively. So I can click on that, look at the report, see what's changed about that, and have a more interactive environment for that. That's really what we're trying to achieve there with that integration. So incorporating that into a workflow with a drone portion of it, this largely speaks to a enterprise GIS workflow. Certainly the drone playing the aspect of the data collection component thereof. Quite frankly, I use say field maps and things of that nature quite frequently just to be able to determine where we have access, don't have access, gate access codes, things of that nature, just to really organize myself when I'm out in the field as part of that. And also leveraging SDE in those environments. So either it being hosting the rasterized data, i.e. the orthomosaic data, other types of data in there, while we're hosting that with other sources as well, but then using our GIS server to better leverage some of these technologies and integrate the two. So pros and cons of cloud-based photogrammetry. Just talk about this. I literally was on a call about this earlier today as part of that. So we see a couple examples, the lower right corner being Metashape, the upper left corner is a screenshot capture from drone deploy. And what are those pros and cons? I can take my drone imagery at a high relative accuracy, process it in the cloud. I can also port that over as a tile service within my web application and be able to have that there live to be able to look at in that web application. One, we don't have to spend the time to host the data, migrate it over to SQL, anything like that. I don't have to host that within my ArcGIS Online environment and it eats up credits. I can have the person processing the data also hosting the data and just leverage that as needed for it. So some of the drawbacks being, or actually one major pro is the passive processing, uploading the data and being able to have that portion of it just done working while you're sleeping. Especially when you're doing a lot of data acquisition, that becomes quite a bottleneck. The other cons being the limitation of the control of the data processing variables. Some cloud-based systems are getting better at that, allowing you, say, to increase key tie points, other aspects of that. I have not found an option that I really enjoy using that's cloud-based that also takes into account. Therefore, I tend to use one or the other path. Quite frequently, when processing data, and I know I need to get to a survey-grade deliverable for that, and using Pix4D map or Metashape, what have you, I'll go that route, but I'll still just throw it up in drone deploy, just to have it for posterity. That way you can pull it out and say, hey, look at this, and hand it over to people. Another key restriction there is the licensing thereof, being able to give client access, being able to give internal access to that. A lot of times we'll facilitate that through the building of a web application that is referencing that data, rather than give it to the client directly, just because of those licensing costs that are associated with that. So mobile data collection, a couple pros and cons here, or not pros and cons, but a couple key attributes hereof. So I won't read out all of these and just speak to the generality thereof. Really, there's a lot that we're still not doing with photogrammetric data as far as even the hosting of 3D models. And I'll get into that a little bit later here in the conversation for that. But just better leveraging more and more project deliverables and getting them accessibility and using GIS as that primary means of that tool. Here's an example from a project for the city of Raleigh. It was largely dam inspections and BMP assessments, so catch basins, or catchments there as part of that. We're using UAS to do annual surveys of different assets, say in this case for dams, but we're also using survey 1, 2, 3, other aspects of GIS to be able to go out and collect that data. You'll see there is a key point there. This is taken from drone deploy, where we found an asset or there's an issue with, I think it was a pipe that was leaking there in that particular instance thereof. But really just harping on repeating data collection for cross comparison, just for change detection. And more so, the key aspect that the client was looking for this is that they may be responsible for the asset, but they're not always being in charge of maintaining that asset. So going out, and vegetation is a huge concern thereof, in vegetation management. So being able to go out and say, okay, this is what it looks like now. We've sent you a letter about this. You need to maintain the vegetation around there because that will cause more infrastructure diminishing, cause damage to those dammed areas for that. And that way we go back the next year and says, did they assess that vegetation or not? And we have proof and evidence thereof that allows us to better leverage those sorts of cost avenues. So, yeah, the computer. And then talking about the 2D and the 3D comparison, you see the slider bar there between the two different sets of data as it looks. This also compares on the right-hand side two types of data collected on different devices, or different types of UAS. So the further restoration project, this was done in Wake County to look at a stream restoration project post-construction, as well as other grading that took place upslope of that restoration. Just to show really a project example, but also look at what that can mean for the long term for that stream restoration project, i.e. better assessing the grading that took place to see if the sloping is going to cause any further sediment erosion issues with that, and then also creating a baseline for this remodeled stream as it's been restored back to functionality as part of that. You'll see a number of ground control points taken here, as well as checkpoints that were taken along the river for other types of. So while we were out there collecting data, we were also collecting other types of data at the same time, not just what pertained to setting UAS ground control and checkpoints. So what can we do with the data long term for this? This is a visualization, is a 3D scene within ArcGIS Online. We also see some of the components there over in drone deploy on the left-hand side. In this particular case, it was a landslide project that we assessed 1.5 miles of road in a given county, and that was mountainous. We were also heavily restricted to where we could fly, only within the right-of-way corridor thereof, so shoulder to shoulder with that, which created some limitations, especially when it came to capturing oblique imagery and being able to process that imagery in a way to give a vertical or facade orthomosaic of the rock faces in various areas thereof. It's another aspect of it too, with limited data collection thereof. And this is a sparse point cloud in here on the left-hand side, what that comparison looks like between the model. We also consequently picked up the railroad track there because it was in the purview of the data collection as part of that, and that can be used as a secondary deliverable. So LiDAR, I won't go too deeply into this. I just want to give a couple lessons learned thereof. I think that's pretty much everyone feels like they're probably caught up to speed on what the LiDAR capabilities are and what that resolution can look like for that. Here's a couple project examples thereof of data derived from there. A levee system, we do a lot of work with levees for some reason. It's just coincidence to whatever type of work that we get coming in there for that, as well as tree canopy vegetation penetration for the purposes of creating as-built elevation models. And here's an example from a recent project. So that is the data here on the left-hand side. You see what could be captured photogrammetrically. Below that is data that was captured via LiDAR that was being flown for that time. Certainly a night and day contrast to what you have accessibility to be able to see. We're seeing a lot of really interesting topographic features pop out of that LiDAR data set. To capture this at this 400-acre site, we had to stick someone on a scissor lift to be able to do that. I can say that was not me because I would not be doing that. I am terrible with heights. But putting someone up on the scissor lift to be able to maintain visual line of sight as part of that became a necessity. with all the other logistics of getting the scissor lift, getting trained on the scissor lift, getting everyone out there, the scissor lift breaking for 30 minutes and having someone up in the air, not great, and then having to do that. So it certainly took a little bit longer than anticipated, but well within the scope of the project. All right, I think this should start. So now we're kind of pivoting and looking at large-scale assessments. This goes back to the integration of the BV loss technology as part of that. So we're looking for doing annual inspections for encroachments, homesteading, illegal dumping, and just really large-scale mapping as part of that. Just once again to go feedback into change detection and just to do those annual assessments and reviews thereof. So we're using the mobile data collection for the tracking of the completion of those assets. So i.e. I went to this parcel, I flew this is where the status is at. And that way we can give that level of transparency back to the client through a web application, say, all right, well, they flew it yesterday, it's in data processing now, and eventually we'll move on to step 3 where it's been completed and the data has been processed and posted onto that same web application thereof. So I talked about gate access, property boundaries, things of that nature, just knowing the limits of the site, and especially as that pertains back to project planning, to make sure you have sufficient coverage of those sites. And then those primary data deliverables being orthomosaic maps, 3D meshes, and then the fly-through video thereof that we're seeing here today. We're moving on to another phase with this client, a federal client that coming this Tuesday, we will fly the first on-cantonment site assessments for the Marine Corps. It's kind of exciting. We're using it for construction monitoring assessments to do these quarterly at 60 different sites within there. I would love to chew someone's ear off about that later if they would love to know the legalities that went into that. It was a lot of work to get from point A to point B to gain access, as well as acquiring specialized equipment for that. There you go. Let's see. So this is a picture of the census takeoff video there. Just to get an idea of what that VTOL aircraft is capable of. You send to 150 feet. Sending a command to the unit to send it to another flight formation. It takes the front rotors, pivots them forward on those, on there, and you see that forward flight movement that happens. So you see the diagram there has two servos in the front that articulate, and you essentially give it a little forward momentum, tell the servos to articulate down into a fixed wing format, and then it's able to take off, flying at a speed of 40 miles per hour as part of that. The harder part's landing it. It is not easy. There's a lot of wind that's generated there, and you get a nice little pocket as you're landing thereof. So for scale, that's 5 feet on that landing pad thereof. I've just been told one of the suggestions that came from this is just buy a larger landing pad. It certainly helps to protect the equipment, rocks, things of that nature, the camera getting a rogue rock and cracking a lens and things of that nature as well. Okay, so BIM integration in GIS. I'm going to go ahead and cut to the end here for that to talk about this specifically. There's a lot of good conversations that are happening today about SLAM algorithms and being able to incorporate that. But the idea of incorporating this into a GIS as part of that and what we want to see from that, and how can that be made useful, especially in the indoor-outdoor space thereof. I'm going to jump ahead here. Like I said, I did far too many slides. And where we're seeing future growth thereof, magnetometry, air quality monitoring, methane detection, GPR, UXO, and vegetation mapping thereof, as well as finding solutions for remote ID compliance thereof. These are some of the challenges that we're currently facing that we're working towards and where we're seeing potential growth thereof. Nope, forgot that, Heather. This is an M300 flying to do a pole assessment thereof. You get an idea what that looks like. Getting up to flight altitude to look at that asset. All right. So summary of benefits, just to look at the combination of using the GIS data, field data collection, enterprise GIS, along with UAS data. to be able to provide unique deliverables as part of this, and then co-collecting UAS and field map data as part of that. All right, thank you, and please ask any questions you have available. 4 times you were in that video. I'm so sorry. I know. Yes, sir. Oh, absolutely. So the question was what platform we're using on the Marine Corps base. We're using a Skydio X2D. To elaborate further, so you might be aware of the Blue UAS initiative as part of that. Just because you have a Blue UAS does not mean you have certification from the various entities and certifications thereof. So the only one that I have found to date, and I'm working through this with a couple manufacturers, is that Skydio X2D for that. We're also looking at the Inspired Flight IF 1200, something that can carry LiDAR eventually for that client as part of it. But even they don't have that certification, even though they have a Blue UAS. So it's complicated. I'll say in a nutshell there. Cool. Yes, sir. Mm-hmm. Oh, I'm sorry, for the BB loss, what portion? Mm-hmm. Correct. Mm-hmm. Oh, great question about, yeah. So there's still airspace authorizations and waivers that we needed to gain in order to gain access to that. We initially got it approved for one larger area where we were working, and then now we're working on having a non-geo restricted version thereof. And that, once again, is just a waiver process with the FAA. The bigger thing is that there's still a VO component to that, even with BB loss and navigating that. But essentially what that BB loss threshold allows is you to add another half mile to your visual line of sight and still maintain compliance with the FAA. It's really the certification or the waiver process that we went through really had more to do with linear projects, i.e. can I daisy chain VOs to be able to extend that line of sight. But where we find it most effectively is one, collecting a tremendous amount of data and just having us have a little bit extra buffer and planning flights around that so as to maintain compliance with VOs. Ooh.
Any other questions for the speaker?
All right.
I want to add one more thing for the kids in the room, just so you guys know, there's every 1 hour of drone flying, there's many more hours of processing goes on, and there's a little bit of actionable information that comes out that relates to real life, that has real life implications. So this is very cool stuff. Let's give it one more hand.
Thank you.